The crib drag project, so I just want to talk about it briefly and give you a few more tips that will help you. Here's the crib drag. So here you see how it works. This is the active ingredient. You do an XOR operation between bytes of key and bytes of text. That's how you encrypt, and it's also how you decrypt. So this will decrypt using a key and a ciphertext. And if you do it for two ciphertexts, you'll get two things. And the point is you have to guess what's in there. And the thing I thought I'd mention is, here I tell you the key starts with the. And that means you have the first, when you use the right key, you will see readable stuff here, NEV and YOU. When you have the wrong key, you'll see random garbage like this here. Punctuation marks, unprintable characters, and stuff like that. That's your clue. That's why it works. Now here, you have to figure it out. Now what you can do here, these are two ciphertexts. Now the key may not be a readable sentence. In principle, it ought to be random letters. In fact, I never made it that random for these just to make it easier. But the message should be a readable sentence. So what you can do is you can start by filling in the message with a guess. And the best guess to start from is probably this one. This is what I usually use. It's space the, and you repeat that many, many times. And so if the word the appears anywhere, and it usually does, then you're going to get 5 letters in a row that turn into readable text. The and the space before it and the space after. And if, by the way, you should try this a few different ways. You should try it there, and there, and there, and I guess even more. Since I'm trying to get 5 letters, there. Now I think there are 5 possibilities. So you should try all of these guesses and see if any of them produce a group of 5 readable letters in the other plain text or in the key, because that'll be your clue. And as long as the word the appears in either of the messages, this will give you a start. And once you have a start, even a few letters, then you can just guess one letter to the right and the left, guessing a letter or a space. This is the way it works. And you can guess either the plain text of either of these or the key. And I think, so that's an idea how to get started. But you should be able to pretty much use the code that you had up here that decrypts. Just modify it to decrypt 2 ciphertexts and print out the answer. And I even made mine so it's interactive, so I can fill in one letter of either any of those 3 and see what happens. But you could just keep going back in the source code and adding one more letter here and there to get there. Like I say, people did this with no computers in like World War II. You don't really need a computer at all. It's not that difficult. Anyway, but you're getting started. This is the kind of thing you do to get started. And by the way, if I was to do this and it failed, I would probably try this. This would be I forget, the word A must appear somewhere. And so try 2 of these. And then you'll get 3 characters. Somewhere there'll be an A, and you'll get 3 characters that will come clean. So these would be ways to get started. You could take any common letter. I suppose you could take a period followed by space. That's probably in there somewhere. Guess anything that's common. But the is my favorite because you get 5 characters, and then it's real easy to spot what part of it has become readable. Yeah?
Is that like the traditional way of how hackers guess your password? They kind of like get the...
No. We're doing that in another project. This only applies to the one-time pad programming, which is almost never used. Okay. It's the most perfectly secure system, but the key distribution problem is so difficult that almost no system ever uses this. No, the way hackers get in passwords is by just using lists of common passwords, and you'll do it down here. One of these, I think it might be this one. This is the one that had a list of 1 million passwords. Yeah, this one here, you actually download a list of 10 million passwords and use it to crack a password. And if I'm probably going to go back to that, I'm planning to write a Bloom filter one where you get to see how fast you can look through a list, and you'll show that looking through a list of 1,000 is just as slow as looking through a list of 2 million.
Oh, shoot.
Bloom filters have order 1. You can look through any list no matter how long it is with the same speed, because essentially it's an array, what we just talked about. Anyway, so that's all right. That's old business.